we do today, based on that, things will happen in the future, and these are the options which are available to us. Now, I talked to you about renewable energy, right? And renewable energy, what do you think? Look at these 5 options. Energy available naturally, energy that does not result in carbon dioxide emissions, energy that has no losses of conversion, all of the above, none of the above. How many think it is one? Out of these 5, you think of one option. And just raise your hand if you think the correct answer is 1. Anyone? No? Correct answer is 2. I think people are 3. Okay, I think you are not willing to sort of answer. The correct answer here is actually none of the above. Because fossil fuels are also available naturally. Fossil fuels have happened over thousands of years of pressure and weight on the vegetation, which has become coal, oil, natural gas. Energy that does not result in carbon dioxide. You have biomass, which is renewable but can actually, all renewable energy has losses of conversion. So the actual, I bring you this to define what is renewable. Renewable and non-renewable. Non-renewable is depletable. Renewable is that the energy gets renewed despite the usage. So in the solar PV plants that you have on your campus, the fact that you are using the solar energy does not affect the amount of solar energy which will be hitting your panels in the next year or the year after that. Right? So this gets renewed despite the usage. That is not true about the, now even when you talk about coal, oil, natural gas, they do get renewed. But they get renewed over a long period of time. The rate at which we are depleting is much higher than the rate at which it gets naturally renewed. So this difference between these two gives us the definition of what is renewable and what is not renewable. Okay, this I hope that is. So the rate of renewal minus rate of depletion. Okay, another thing which you need to understand is that for all of us, we don't have a demand for energy per se. It's not like, you're talking of a certain amount of something that you consume, right? You have a demand for that. What we have in this room, you want to be able to see this projected. So you need a certain amount of lumens or light output on this. You don't really care what is the rating of that, the bulb in your LCD projector. If someone tells you this LCD projector, probably it's about a 200 watt projector. If someone tells you I'll replace this with a 15 watt solid state lamp and give you the same output, for us we are indifferent. So we don't have a demand for energy. What we need is, we need the energy services, distance traveled, illumination, cooked food, motive power, useful energy. In order to do this, it goes through a sequence of conversion steps. And if you remember your thermodynamics, theoretically everything is a reversible conversion, but in actual practice, you have irreversibility. So if you use 1 unit, you are using 1.5, like you are using a certain amount of energy to make the conversion happen. And so you have this whole series of steps, and one of the things that you can do is try and make all these steps efficient so that you can get the same useful energy while using less of primary energy or the energy that is available in nature. And just to give you now, what I've done is, you can take aggregate what is the total amount of energy used by India and the world. And if you see this, you will find that we are 1.4 billion out of about 8 billion population, which means 17 to 18% of the world's population. And we are on an average poorer than the average person in the world. And you can do that, you can do the per capita consumption, We have only about 8% of the world's GDP and about 7% of the world's energy use. 600 plus exajoules, about 40 exajoules that we use, and per capita energy use is only about 40%. So naturally, the CO2 emissions for an average Indian, and which is averaged over the villages and the cities, is about 1.8 tons per year, which is lower than the world average of 4.3 tons per person per year. And how many of you have heard of the tragedy of the commons? How many have heard of tragedy of the commons? Okay, so tragedy of the commons means essentially there are certain things which are common resources. And the classic paper by Garrett Harding, 1960s or so, is that there is a grazing land and there are many different farmers who own cattle, and there is a common pasture where the cattle graze. Each farmer tries to optimize the output, maximize the output by having more cattle, and all those cattle comes to the grazing land. So the optimal thing is maximization of profit. Everyone is doing that. It goes on till the point where there are so many cattle that the grazing land gets denuded, and the whole system collapses. CO2 problem is very similar to this. You have different countries, each one is maximizing the same use, and they are using fossil fuels. And so we have to get together to decide how much CO2, what is your right to pollute the global commons? How much should the US pollute, how much should India pollute? And the interesting thing is, we never could get an agreement. The simplest thing that whether you should have an equal right to pollute per person, or it is dependent on your historical pollution level, has never been agreed to, because all the northern countries, all the developed countries have been polluting much more. So finally, since you could not get to a balance on this, what we said is, okay, we sign an agreement in Paris where everyone decides how much they will contribute. So this is the Paris Agreement, voluntary commitments, right? And that is what has happened. And then, of course, this is an ongoing story. And of course, now with the new US election, it is likely that the US will get back from its Paris commitment. We'll have to see what that means to the world. Okay, this is sort of an energy balance if you sum up for India. And predominantly, our energy is predominantly coal, followed by oil, and most of our oil is imports. Then we have renewables. A large proportion of the energy that we use goes into electricity, and then of course you have renewables is there, but renewables is relatively small in this. It's a growing portion as we go ahead. So let's look at the power sector, which is again important. In the power sector, you see that by installed capacity, by the rating of the plants, about 50% is coal, and but by generation it's about 70%. And then you see what happens here, and we go back. And some of you, I don't know, have any of you visited a thermal power plant? Any of you visited? Okay, great. So you'll see in a thermal power plant what you have is you have coal being burnt in the boiler, then it goes, you have steam generated, that gets expanded and you get work, that work gets converted into generation, electricity, a generator, and then gets supplied to the grid and you get electricity. And so this has been the conventional way of fossil fuel burning. And of course, we have similar kinds of things where you start instead of coal, you have a nuclear reactor and you get steam and then do that. Anyone been to Suratgarh? Suratgarh? Okay, great. This is in Rajasthan. I was just trying to see, okay, let's take some examples from Rajasthan. We have a large power plant, super thermal power plant in Rajasthan, 2,800 megawatts. You know, whenever you look at this number, you have to compare it with something. Compare it with this campus. Requirement 1.5 megawatt, 2820 megawatts, gives you a sense of it. 6 units of 250 megawatts, 2 units of 660 megawatts. These are supercritical and more efficient, where the steam conditions are higher. And we will look at, when we look at renewable, there are various options. I'm going to talk to you a little bit about solar